Can anyone hear me?
Yeah, I can hear you a little.
Okay.
We'll just start and then start talking until you got a normal voice.
All right.
All right.
Are we
When it
starting
drops, you'll
or
know.
are we doing a test still? Are we testing?
No. Go.
We're going. All right. Great. Thanks everybody for coming out. I'm Peter Edwards.
I'm Fred Owsley.
I wanted to say thank you to Jason Scott and to Fred for asking me to come out here. This has been really exciting. I just learned what Rickrolling is. So, I think the whole trip is really worthwhile.
Now you can say you learned something.
Yeah, I learned something here at NOTACON. So we were asked to come here and talk to you all about circuit bending. And we both come from different fields, but sort of meet in the middle here in circuit bending. I don't know. Well,
my background is computer security, and I've been doing that for a couple of years now. And just always had an interest in taking things apart and working electronics and trying to make music with it. Trying to be a DJ in my spare time, but that's not really working out. Your background is more of artist, isn't it?
Yeah, so I went to art school, studied sculpture, materials working, building functional objects, which we're going to talk a lot more about this, or a fair amount more about, but I think that's one of the really exciting parts about this medium, which we're going to define and talk about, is that you can come at it from so many different directions, and all sort of meet in this one happy common ground. Right. So why don't you read? We've got an initial definition.
Initial definition here. Just sort of talking about, what is it? What we're trying to nail down what circuit bending is, and it's a lot of things. But more than anything, it's it's experimentation, and it started out with short circuiting, and it can go from that to anywhere. It's amazing the limitless amounts of noise you can make out of toys and other things.
Well, I'm just gonna, if we could go back just for 1 second, and one of the things that, basically what the initial, more like sort of purist definition of circuit bending, which is, it's sort of forming the definition of what this medium is. But I think the initial definition that kind of sparked the interest was that it's sort of exploiting malfunction. So you're using circuitry, often digital circuitry that has banks of sounds or complex signal routing systems, complex synthesis systems that are being confused. So, it's being made to do things it's not supposed to do, but instead of stopping, instead of just breaking or not working, it plugs along anyway, and it starts doing some really weird stuff. So the novelty is sort of the on-ramp for a lot of people. So, as we showed here, the art of selectively short-circuiting, uncovering bizarre new modes of functionality. So there's a lot of reasons to do it. And a lot of us have different reasons, but here I think are some sort of highlights.
One thing to speak to for the accessibility is that a lot of these things were just simple toys. Like I got this Play School keyboard, which I'll play in a second, at a thrift shop for I think $3. And it was one of the first things that I pulled apart and started bending and putting knobs and switches and all kinds of other touch points on it. And it's one of the appeals is that it is so accessible, and these things are quite easy to find if you just go look for them.
Yeah, because you're using basically like obsolete materials, and
a lot of times,
and we're in an era where planned obsolescence is such a powerful marketing model that there's just an abundance of free material to use. So I feel like it's a really good time to be involved in a medium like this, where you're taking all the garbage from the world and you're actually able to do something creative with it. And another, I think there's a real sort of punk DIY sort of feel within the culture of circuit benders, and I think a lot of that is due to the act of circuit bending is a very creative process in a lot of ways. You're experimenting in the same way that you might experiment with other creative mediums of paint or clay or how else do people make stuff? Plastic. So it's a creative process of exploration, but you're dealing with very complex electronics. So that's something I've done with a lot of people. I did a class for a while called Creative Electronics, and we did a lot of circuit bending. It was an electronics class, but you started out with circuit bending, so it was at a real liberal school, not a very technically minded environment. and people were interested in playing with electronics, but it's a very daunting medium. So this is a way to sort of start getting involved before you really understand the intense complexities and confusion of electronics. So yeah, to put a face on what we've been talking about, here's a couple pieces. These are just to show you sort of a range. So, you know, in the top corner, like there's something you would recognize as a very musical thing. You've got a guitar pedal.
That was easy.
And then this is something that Fred's been working on.
So we have a normal easy button that's, you know.
That was easy.
Yeah, then we have the easy button that has just been add an optoelectronic eye in it, so you can hit it and add some light to it. Maybe.
Do you need another one? It requires light.
No, where's the other one?
Here, we can take. Not so easy.
Supposed to work. All right, back into the box.
And this. So this is a.
That was easy.
So that's a real like basic clock speed adjustment, and we'll talk more about some of the specific adjustments that you can do, especially in the workshop. Here's another piece which I showed briefly before, but I'll go over it again. And that's up all the way. I don't know if I can get any more volume here. So this is taking something, I don't want to go on too long about this, but this is taking a real complex speech synthesizer and working it to do some really interesting things, like and while I was testing this in my hotel room before this lecture, it did something really crazy that I had to record, because these aren't always predictable, so I didn't know if I'd be able to get it to do it again. So this was this thing, and I just threw a couple switches, and it started doing this for some reason. It'll go again. And what's really interesting about that is I've been working on speak and spells and maths pretty heavily for a couple years, for 8 years, and I've never heard it do that. So it's a medium that, you can, it has something really valuable, I think, creatively, that it doesn't do the same thing all the time, so it shows you something new, because if it always did that, it wouldn't be that big a deal. But it has some amount of controllability, some amount of predictability, because if it was completely random all the time, then it wouldn't really be useful as a musical tool, I think, in my opinion. So I think this is like a really nice, middle ground. And then there's also more traditional, like, musical keyboards and drum machines. Those are great to work with, and they can be tweaked in different ways. So some of the basics. Do you want to?
Yeah. First thing, start with a battery-powered device. A couple reasons for this. One is that your 120 can kill you.
Yes.
Plugging into the wall, not always the best idea. Also, battery-powered devices, you're less likely to completely fry any components inside if you have a battery-powered device. You can always put in batteries of lesser power, some that might be a little bit dead, or put a box or the resistor in between so you can dial down the power, make your own sort of variable power supply, which you can hook into any toy and give it a lot less juice than it should be. And even that can be used in bins. Like, this is a Musini. I don't know if any of you know what this is. It's a child's toy that the kid dances around and it makes noise for the kid. But it has I put in it a...
Oops, you just fast forwarded.
Oops, sorry. So a rheostat here, which I've dialed the power down. And usually it's, 6 volts. And so it's probably running on 3.5 right now. So that's normal. Kids dancing around, it's making noise. And then we'll play more with that later.
So the next, basically, yeah, you're less likely to hurt yourself and the device if you stick with battery powered. And by the time you know why that's actually dangerous, you'll probably know how to avoid it because there are ways to work with things that plug in, but at first you definitely want to stay away from that. So okay, the next thing is you choose inexpensive devices, and that's because you're going to break lots and lots and lots and lots of stuff. Except if you're incredibly intelligent and careful, like Fred here.
No, I've trashed drum machines. I have a couple on
I've
the floor.
got a mountain of broken stuff, just tons and tons.
That's part of the learning process, though.
And part
break
of
things.
what makes it so incredibly rewarding when something is, a successful bend. But again, it's creative. The process itself is, at its core, it's a creative process, and it's you don't always know exactly what you're doing. You don't always know exactly what you're going to come up with, and that's part of the sort of beauty of the medium. And with that comes along some of this unpredictability of whether or not you're going to break it. And there are ways to avoid that over time as you learn what you're doing. But one of those ways to avoid that is you avoid large capacitors and power supplies, because when you're poking around, if you can learn how to identify those things, you're less likely to send a very powerful signal through very delicate components. In some cases, that can do really cool stuff, though. Every device is engineered differently, uses different technology, which is part of choosing inexpensive devices so that you can get lots of devices. You want lots of stuff to play with. And this is something I see a lot of people run into that's a problem, is that they want to get two pieces, and they want to buy one switch and one potentiometer and have everything work perfectly, and that's too controlled to really come up with, I think, in my opinion, some of the really exciting results that can come from this process. Yeah. And then there are some other ways that you can refine the bends and general things to look for, if you want to take it from there.
Yeah. Large ICs and pairs of ROMs. A lot of the drum machines I've been working with, they do have two ICs, integrated chips, integrated circuits, that hold all the samples for that drum machine. And usually they're of a certain maker or of a certain model of EEPROM, and if you can find that maker model, one of them is the Alesis HR16 drum machine, which I've recently trashed one of them. But you pull the chips out and you can read that on a chip reader, an EEPROM reader, into the computer, and I've bought chips where you can reprogram these EEPROMs and put new samples into the drum machine that you can then bend. So researching the chips that are in certain things, if you can remove them, if they're socketed, or just desoldering them, and putting new samples onto different chips, and researching how it stores, how a certain EEPROM store data is a good way to get new sounds out of things that you might not want to
Which I think is a fairly advanced process of reprogramming ROMs, which I haven't gotten to. But I do a lot of trying to identify what different ICs are, because there might be one that is the synthesis chip. And if I can identify, that's where all the that's the brain of it, and that's where it's saying play these oscillators through this filter for this long, cross-modulate it with this, whatever. And you start crossing that with AD converters or other types of data transmitters, it ends up doing lots of really kooky stuff. Or you find, you might find an audio amplifier, and then you can use that, you find the input to your audio amplifier, and you can start poking that around the board and find different kinds of signals that exist in the board. So it's a very kind of non-exact science, but it can also get to be very exact. But regardless of what approach you're taking, you need to have a clean workspace. This is something that I push with anyone. And that doesn't need to be pushed with a lot of engineers maybe, or people that understand electronics and work with these really delicate processes. But a lot of the artists that are going into this medium are used to having these really messy spaces where you don't need to have a very clear space, but you're really fighting against yourself if you don't. So just thought it was worth mentioning that as well as sort of a core rule. And along with that goes, of course, organizing your materials, which we're going to talk about now, materials and tools. So yeah, we thought it'd be good to mention, just sort of to bring this into the real world, like how you actually do this, what tools are necessary. And again, a lot of people really want to use the bare minimum. And I've found that I can't go without having all of these tools in my workspace. And there are definitely like good quality tools, bad quality tools. Sometimes you don't need the best quality. It's all what's appropriate to your process. But
you might sort of ask why there's a hand drill and hand files at the top. And a lot of the work put into these requires molding and modifying plastic. So you can get great bends and get cool things, but if you can't get it back together and make it functional, or if it's too delicate, it's good to make it so that it'll stand up for a while and not break unexpectedly.
Yeah, no, I'm glad you said that, because that's a big part of bending when I talk to other people, and I see this a lot in the different workshops I've done, where people will make something do something cool, and then they're like, great, it does this cool thing, but then what? Like, how do you actually house that thing? How do you actually make it so that the controls are accessible? I always say that like the interface itself has an enormous impact on the type of sounds you make, the way that you interact with it, the type of audio output that comes from this device. So, the ratio is like 50 to 70% of the whole process of circuit bending is actually working with plastics and working with metals and wood. But like it's not even as much electronics as it is just physical, sculptural, or mechanical working. So that's why there's lots of hand tools. We've shown 2 soldering irons here. That's of course one of the most valuable tools in your circuit bending studio.
On the left, we have the more typical sort of Radio Shack 15-watt, 40-watt soldering iron. On the right happens to be a Weller ESD safe, pretty nice soldering station.
And as Fred said earlier, the one on the left is basically a wood burner.
Yeah.
And that's about all it's
And the one on the
for.
right is a soldering iron.
Yes. So I always encourage people who are getting started to put, just if you think you're going to spend more than a day a week doing this, get a good iron. It's $120 or so, and it makes your life so much easier. That's one of the best purchases I've made in years, was getting the Weller iron. It's fabulous. And it stays clean, it's precise. The Radio Shack ones. I used to keep all of my old Radio Shack irons. I had about 40 of them, just like a big bundle, because they break in a few months. They're total shit. So yeah, we thought it was worth mentioning that. So then you need, of course, materials. And it's really important, in my opinion, to have a variety of materials. Because, again, this is an explorative process, and you don't know what you're going to come up with. So you might come up with something that requires 100K potentiometer, and all you have is like 1K potentiometer that you bought at Radio Shack. And in order to allow yourself to really explore, you need to have a variety. I'll let you go for a little, because I've been talking a lot.
We have just some photos we grabbed off the web. Switches, anything, toggle switches, micro switches, all kinds of things you can buy, repurpose. You have some old electronics, you find some stuff that might be broken. I've bought things just for switches, like swap meets. Oh, that's a cool light, I could use that. Potentiometers, I bought just old potentiometers, big resistors or rheostats, whatever you can use in something. And a breadboard, which is on the left, very basic tool for prototyping electronics. And also can be used in circuit bending, which I'll show you at the end. A breadboard hooked up to a DB25 port. And this is modular. It can be plugged into anything that I wire a DB25 port into. Plug it in and just start bending by moving the wires around and crossing different pins here.
Right, so he has the breadboard wired to this jack, each pin to another row in the breadboard.
So I'll show that off at the end.
And just for anybody who's not familiar, we just have some pictures of capacitors on the top, resistors on the bottom. There's common electrical components. I've been able to get by doing a lot of circuit bending for several years without actually having any of these components. But it's very useful to have some around and start experimenting with adding them into the circuits. Transistors should be up there as well, but they're not. So where do we get the tools? There's a lot of different places to get this stuff. There's always the wrong places to get this stuff, though. You usually don't need to go to like specialty stores, I think. Like Radio Shack is last resort for everything, ever. They're awful.
Tag sales and swap meets are great places to get tools. As long as they're not, worn out, as long as they're sharp or you can sharpen them, you can get some, really great tools at, really decent prices. You're not paying full price for a brand new tool, which that you might beat up or break. Especially files, anything it's files that are still sharp, hand files, that type of thing, hand drills, drill bits.
And this would be a topic for another talk, but my slogan has always been anything you could ever want is being thrown out somewhere. So a lot of the stuff I've gotten is from the trash. I also lived in a college town for a while, and at the end of every year, they would get rid of lots of stuff, like lots and lots and lots of stuff, and I would just load up on electronics and printers and printer ink and tools and just all kinds of stuff. So I've gotten a lot of stuff from thrift stores, tag sales, like boxes on the side of the road that say free.
I got a Commodore 64 that way.
Yeah. So I mean,
it's on the street.
It's what is it? One man's trash is another man's treasure. And that's where again you're kind of playing in this idea of using obsolete objects. So and that can be tools sometimes, quality tools too. So
the big question.
Yeah, the big question.
What should I bend? We came up with last night simple but not too simple. The easy button is relatively simple. You only really one function. It plays a recorded voice, but you're still able to bend it and get some different types of noises out of it. But it's not inherently complex like the Speak and Math, as you can get a ton of different types of sounds out of it.
And if you go too complex, you can get things that just don't bend in a way that enhances its functionality at all in any way, or it'll be like a really complex keyboard or a big home organ or something, although those can be fun to work on. But or you'll break something really valuable, or there'll just be too much going on. Like it's good to have something where you can see like there's the synthesis chip. That's where all the sound's coming from. But when you've got like a whole complex system of like it might be coming out of one area, but then it has to be multiplexed with something over here, and then it needs to be amplified and then mixed, and then it's going through all this different stuff. It can be really hard to isolate the real like meat of the piece.
One of the first things I started out with was this Play School keyboard. Like I said, I got it at a Goodwill. It was like $3, and fairly simple as far as the boards inside and the patches that were made. The soldering points are big, though the chips are big. There's not really anything discrete and really tiny, hard to solder onto. So it's a great thing to start on. One of the other things that I picked up kind of recently was
This is a great
Roland 707, predecessor to the 808 and the 909. Vintage drum machine, and again, it doesn't look bent at all. Maybe this knob, but I just lost the knob. But here's the port that I was talking about, which you can patch on this breadboard like that. So there you have. This is wired inside to the two sample chips, and you can just sort of patch bins in between the two chips.
And what does it sound like, Fred?
Great question.
Wait for the muse.
Yeah. I'm using telephone interconnect wire.
So you're able to do a lot of different effects, ranging from kind of subtle to pretty extreme, and you can isolate different sounds. Some bends will affect everything, some will affect just the bass drum. again, you just sort of experiment, see what you come up with. This is something I worked on when I was just starting, and I broke a whole bunch of them, and they're kind of expensive, and I should have waited. And this is a piece that's like great on its own too. It has individual outputs for all the drums, MIDI control, and a bunch of other stuff. But this falls pretty well in the range of like, simple but not too simple, but also complex but not too complex. It's like a nice middle range piece, and they sell for about 100 and change.
Yeah.
So yeah, then I say again, cheap toys because you're going to break a lot of stuff. Drum and keyboard toys like that, the Furbies, anything that has a speech synthesizer. And you'll recognize the difference between a speech synthesizer and a sample is, sample playback will have, like, there's a person in a room with a mic who's recording samples, and a speech synthesizer, it sounds more robot-y. I don't know how to really explain it. The Furbies are all speech synthesis. They're incredibly complex, advanced little robot toys. Here's another crazy.
It's actually a voice changer. It's a kit from Velleman. And it's not exactly circuit bent, but it's in a creative casing at least. Let me see if I can turn it down.
It has lights.
Hit the other buttons to get all kinds of robot noises. Oh, crap.
There's the very low voice, but it doesn't want to use on the news when they don't want you to know who's talking.
Yeah, this is that my normal voice? Yeah.
Sort of, yeah.
That's not interesting at all.
Okay. But the robot or the vibrato voice is way more interesting. And of course it fogs up because I've taken up all the anti-fog out of it, I guess.
Yeah. And this thing makes you crazy when you wear it too. So.
Apparently. Oh, jeez. Where are we? Yeah.
Yes. Anything that modulates sound, guitar pedals, speech synthesizers can be glitched out in interesting ways.
Yeah. Simple video games. I got one of the Atari retro consoles that you can get now. Not the one that's just in the joystick, the actual console that has Yard's Revenge and all those other amazing games in it. And I broke it open and started, hooked up the TV and started, bending it, and it got all these great video and like Atari noises coming out of it. And it was kind of cool. It's not done yet, so I didn't bring it, but another good thing.
Yeah, so it's not exclusively sound. I've seen people work with video editors and get some interesting results. And again, it's all just this process of just poking around and seeing what happens. But then once you find something, then it takes, at first it's very experimentational, and then when you find stuff, then it takes a level of, expertise or, precision to allow you access to those effects and those parameters. But initially, it requires just a very creative exploration process.
Yeah.
What's the word? Explorative? I don't know. Okay. So yeah, there's lots of places to find stuff. The toy stores are last resort always. Sometimes you can get stuff on like super discount if you really need to get like a bunch of them and they're on clearance or whatever. Clearance, tag sales, yard sales, thrift stores, that's where I've gotten most stuff. And then eBay if you need something specific, but you're always going to pay more.
Yeah.
And you'll start to see different trends if you're like in the market for stuff. So it's like, I needed a bunch of these. I just bought 50 of these for a big project. So the only way to do that was just to go on eBay. I couldn't just search around thrift stores. And you pay a premium. Like, I can get this at a thrift store for $1 or eBay for 20 and then like 25 with shipping. But I can't, I needed them, and that's the only way to get stuff. What's that?
You must have had quite an effect on the market.
For a few days, yeah, or a week or two. Yeah, I controlled
Drive up the
eBay.
Speaking
I was threatening people, warning them off. So yeah, I want to do that. That's what you guys are supposed to be saying at this point. Yeah. So, well, we'll go over some links. I'm just going to go over my site a little bit and show you. I have some tutorials on here, so I'm just going to show you a couple things real quickly.
You can even play some of the stuff if you want.
Okay. So this is Casper Electronics. This is my website that I've been documenting stuff on for a couple years. And what I've been trying to do lately is include schematics and tutorials. I also have a blog on the front. Here's the new Speak and Spell project I'm working on. So there's some other things. I'll show this really quickly. This is a guitar joystick module. And this is part of what I was saying about how the means by which you access the effects will have a huge impact on the types of sounds you make. So he's got two controls on here for affecting the rate of the decay. One is a knob and one's a joystick. And
is that a standard guitar?
That's a regular old guitar that we drilled out and built this circuit into. We're sorry the video is no longer available. All right.
At least you didn't get rickrolled.
Yeah. Right? I don't. Yeah. I always worry that YouTube's going to crash and I'm going to lose all this valuable info. I think. Okay. Thank you.
Thank you.
So he's just affecting basically the playback of the sample that's been recorded. And, so you can hear you're getting types of sounds that you wouldn't get from something that, I'll just play again real quick, that you wouldn't get if he was affecting, just turning it with a knob. So that's a very, sequence type of sound. So, I wanted to show you this. So, here's a few different, type groups of schematics. So you can see a little bit more of the process. So here's one. I've been working with a guy in the UK who does really phenomenal work. He's an electrical engineer who's gotten into circuit bending. So he's been sending me some info, and I've been sort of trying to process it in a way that can be taken in by the average dude. So I like to simplify it all down to one picture. So here's the circuit. That's what you got to do with it. You can just print it out, put it on your workbench. You don't need to. If I have to read 3 pages of text, I'm not going to read it. I think a lot of people are like that, maybe. But I'm one of the billion people with ADD, and I like it to be nice, easily digestible pieces. So here's showing you're going to be connecting to these 3 points on the circuit, connected to a switch, and this is just supposed to give you an idea of the actual physical process, and that it is relatively simple. You're just connecting wires to a potentiometer, soldering them to the board, and here are some of the sounds, and this is a lot more text. If one wants to read about it, they can. I don't know what effect that is. So these are just examples of what all those bends do. I don't know why the labels aren't coming out here. That would explain what they are. But this is an SA keyboard, which is a really great example of what circuit bending, a sort of classic circuit bending effect. So let me see if I can find the other. Okay, the SA2. And this is sort of really simply sums up what circuit bending does. So this is a keyboard, regular old keyboard, and you press a button and suddenly it does this. This is completely self-generated. And yeah, so here's another one. One more. these are, again, completely self-generated sequences. I'm not sure exactly why they do that, but they do. This is a really popular piece. This is the Barbie karaoke machine, which does a lot of really...
Click on that picture. Make that full...
fantastic
Do
stuff.
it one more time. Just make it real big. There you go.
I think, let me see if I can zoom in even closer. Yeah. So, yeah, there's the Barbie. No, those are just potentiometers, old potentiometers.
Is anything on the side? What's on the...
This one?
Output
Oh,
jack, or
that's just another potentiometer. Oh. But this has a bunch of different functions. It plays tapes, it has inputs, and it has an echo, this little echo feature, which is really the magic in this thing.
Barbie is a great mom. She's not too great.
Just talking about Barbie. Nothing very specific. Okay, so here's one, there's a tape playing. So that's a tape playing, adjusting the speed, feeding it into the echo, changing the pitch of the echo. It does a bunch of other stuff.
Did you make that yourself? Sure did. I sure did. Where did you get all those knobs and buttons and dials?
All very relevant sound samples. And then it does stuff like this. I'm kind of going on a bit. So here's Barbie bending. And this is where I talk a little bit about it. I show, here's how to... well, again, it's kind of a small picture here. Here's how to take out the pitch control. It's like a voltage regulator in the motor, and then you can put in your own voltage regulator, change the speed of the motor. There's other ways to do this. This is a fairly quick and dirty way that works. And then, in keeping with the sort of all-in-one page approach, here's sort of the master schematic for the Barbie, showing how you can access, there's like a pin that connects to an auxiliary board, a row of pins with a ribbon connector, and you can actually disconnect that, and if you want to rehouse this whole thing, you can do that and access all the pins there. And then, here's another one that's showing how to modify the echo. And the last part I'll show you, I'll show you this too. This is a double Barbie. This is two Barbies built into one housing. And, this is a real kind of noisy monster, which, let's see if I can get it to play. So this is completely self-generated sound, very quiet sound, but so some of this stuff is a little more musical than other things. This is not musical by traditional standards, but I like it. So, and then I also put up a speak and spell bending thing. And I actually have something here. So here are just some different schematics. And again, you're just going into the speak and spell. Here's the circuit board. And you're just connecting points together with pieces of wire that you connect to switches. This is showing how to make a relay sequencer to turn bits on and off, which is what I have in this piece here, which you can see later, where the sequencer runs. You can see it running here. I think you can see that. And it runs across and it activates different sounds. I don't know if you can hear that. But I'll show people examples of this later, or how that works. And then another example up here of an LFO. So you can modulate the pitch of the speak and spell. And I used, again, the same image here of how you wire in your simple pitch modulating circuit. And I have here, I just did this recently. I took this image. This is sort of like my master schematic. And had this printed a whole bunch of times for this paper in New York. I have them here, which I'll give out to interested parties. I'm not selling them. But this is like a show paper for shows in Brooklyn, and it's outdated, so you can't go to any of the shows, but you can hang this colorful poster on your wall and enjoy it every day. I've already found some errors on it, so you might not want to try to bend from it, but it's supposed to just be an inspiring image. And I enjoyed doing these drawings. So it was a fun thing to do. But yeah, I just wanted to show a couple examples of, the guts of these things. I think we wanted to sort of introduce to people who weren't familiar with this process what it is, talk a little bit about, what you're actually going to need if you want to get into it, and then show a little bit more detail of, what's going to happen when you cut these things open, what kind of guts are going to spill out. And then we're going to follow up with a workshop at 7 in the main room up front. So if you really want to actually get your hands dirty, we're going to be there showing these pieces, working on other people's pieces if they bring them in, sharing vast amounts of knowledge and wisdom.
Yes.
And I think that, so we have a couple links. There's lots and lots of info available online. It was really hard to decide what links do we put, other than our own, of course.
Yeah.
So there's Fred Owsley's page. Mine's Casper Electronics on the left. But again, there's so many people out there doing really fantastic work. And so I think if you just type in circuit bending, you're going to find a lot of stuff. You go to Get Lo-Fi, that's a blog where he talks about different people that are selling stuff, or he'll just list hey, somebody's selling 8 Speak and Spells on eBay. Why don't you go get them? The Bent Festival is coming up in New York, and there's one in LA, and there's one other one somewhere else. That's April, I think, 25th. That's a really exciting festival. There's lots of people. People come from all over the world and show off their stuff, play music. There's a lot of workshops. So all the info you need is there. Of course, Make Magazine is an inspiration to many.
Circuit bending and all kinds of other stuff.
Right. Yeah, there was an issue where they went over circuit bending. But that's the general ethos that this all fits into is getting at everyday objects and ripping into them and bending them to your will. And that's really, I think, something that they embrace. And I don't know who Lady Ada is. Yeah,
a friend of mine who does all kinds of electronics building and has made all kinds of cool things. So.
And that's, again, sort of, I think I remember looking at it, it sort of illustrates some of the ways that this medium spreads out. It has many arms that, reach into lots of other pies and dabble and touch them provocatively. So, it's not all just about taking toys and modifying them. It's really about, beginning this sort of the growth of this little creature in your brain that wants you to take lots of cheap electronics and open them up and start seeing what can be pulled out of them. Do
we have any time? Do we have 5 or 10 minutes to just make some noise? Yeah? All right. Cool.
Okay. So yeah, there's I think a few things up here that we haven't had a chance to show. And then
if you want that, I'll take
we'll be happy to
right
take some
channel,
questions.
and you can just have the left channel.
Is anything that you're going to demonstrate for sale today?
Yes, actually. I'm glad you asked.
Any other questions? Yeah.
This piece right here, the stylish MT4, is currently for sale.
That's fantastic.
Well, thank you.
How much would a person pay for something
This
like
piece is $300. And I've got some other pieces on my site, and some new models that I'm working on, and echo pedals and some other things, which you can see if you go to my site. I just added a for sale page. So here are some examples of what this can do along with the circuit bent drum machine. Yeah, it's not making any noise. Is this DI? Oh, I think it's going in mono.
Will that even work?
Are we up?
Yeah.
Oh yeah, it's the white instead of the red.
And yeah, we are mono.
Okay.
Well, maybe you can make some noise.
Try again.
Okay, so there it is very quietly. So I actually did do a quick sample of this, but just very briefly. Oh, and it does this thing a lot. Is there any way to turn this on?
Yeah.
Which I don't know why this does this, but if you can see, it's backwards, wajuju. Yeah, okay, but trust me, it says wajuju, and I've spent a long time trying to figure out what that is, why that happens. I think it's saying something that my mind isn't really, I haven't exercised enough to really take it in. It would probably have damaging repercussions if I was to try to really understand it. So there's a few basic features that, I'll talk to people individually if they want. I mean, gladly. It's hard to shut me up once I start talking about this stuff. But I can go over the features that this has. But one of my favorite things that these do is this really bizarre looping feature. It does that. And I don't know why, but it does. I like it. And then you can adjust the pitch. But then you can get it to do a loop randomize. So it's doing a loop, but then let's start that over. So it's doing a loop, but then you can make it introduce little bits of random noise into that loop for some reason. So there's lots of like subtle little adjustments that you can do, and then you throw on this other switch, and it starts getting crazy. And then it'll just go. Like I can set it down and let it do its thing. So something that I enjoy doing musically is I'll get a few things like this going, and then I just sort of let it go. And once in a while I'll step forward and it just goes. So it's more like, I feel like it's like I'm in a big room with like a bunch of those big exercise balls or something, and I just kind of like push one and then push another, and they all kind of start dancing together. And then once in a while I need to get it rolling again. So there's that thing. And if Fred, if you want to show. I think we're actually kind of almost out of time.
Almost out of time? One last thing.
But yeah, real quickly, and then we'll be happy to answer questions.
I wonder if this is actually... So I'm not terribly sure what, if I remember correctly, what all these things do. But we have your normal keyboard functions, and it can play a melody. Some pitch bends. And I also added some touch points on two chips that I found by just sort of actually placing my fingers around the board, the circuit board, and trying to find some other stuff. So we have a lower one. And we have so you can play some Happy Birthday, but it's, you don't have to pay the royalty rates for that. And they're just some sort of glitch switches, just making random loops. Then there's a sort of little drum machine rhythm section in here. And there we go. There's the drum machine. Very simple, but. This even has a playback and a sort of memory function where it can play back sounds for you. So everything I just played. Let's hope we can do. Any questions?
Yeah, does anybody have any questions? Yeah.
Yes, of course. How could you not be turned on by this?
Yeah, that's. Yeah, Fred, why don't you
cheap
answer
ploy
that
to
one?
get you in the room. I'm sorry.
Yeah, sorry. We just
Got me laid. I don't know.
we really want to be liked and be popular. So,
All right. Anybody else?
any real
Last
questions?
question?
Yeah. I'm just kidding. Sorry.
Does this work in like a live environment because you seem to lack any sort of predictability, and it seems like between songs you would
Yeah.
have 30 minutes of figuring things out,
Higher.
trying to fix things with soldering irons.
Well, I think the goal a lot of the things we were talking about, like having a good workspace, having good tools, is so that you don't ever have to fix things. They can be built very, very well, so they do not break. So that's whatever. That's an issue of craftsmanship. But as far as how are these musical? Could they be used in traditional musical settings? I think, I'm involved with the Bent Festival, and I was asked to help get circuit bending bands, and I don't really know a lot of circuit bending bands that are fun to listen to, because a lot of it's just noise. And that's a really tough part of the medium, is that, there's sort of this weird thing with 8-bit music and circuit bending seem to be like in the same ring together, but 8-bit always like consumes it, because it's an interesting medium. It has a lot of the same appeal in a similar way, but it's actually fun to listen to. This stuff I've sold to a lot of different clients, different kinds of clients, a lot of rock musicians, so it's basically like rock musicians who want something like kooky to inject in between songs, or like that little accent. A lot of like hip hop guys that want like something that's really like fucking fresh and crazy looking, like they just got that crazy shit. So it's like a CD turntable with a guitar neck on it, and everybody's like, holy shit, it's a CD turntable, or with a guitar neck. So like the real like flash stuff. And then a lot of like experimental soundscape. I do a lot of music with this stuff, and it's a relationship with you and the instrument that you don't have, I think, with other kinds of instruments, where you're saying you're bringing some of yourself to the table, and they're bringing some of what they do to the table, and you're sort of working together. I don't want to get too like, I don't know, weird, heady about it or something, but like you're really working with each other as opposed to just controlling an instrument, which I know that most instruments, they have like their own things they bring, and physical elements and parameters that are limitations that you need to work with. But this is, I think, an entirely unique kind of process of, embracing elements of unpredictability. And instead of trying to eliminate that, really kind of celebrating that and bringing that into your composition in a way that strengthens it, which is possible in certain types of music. So,
You have a question?
Well, I was just going to say that, I was just going to say that I don't think there are some artists who probably don't use it as an instrument itself, but to generate a sample that they would then work into something else. I mean, I've heard a lot of, well, that was new. I've heard a lot of more recent industrial, that's not actually tape loops of industry, but of broken stuff.
Mm-hmm.
Doing basically that.
Can I try a stab at that?
Please.
Yeah.
Introduce yourself. Please, would you introduce yourself?
I'm George Sanger. I'm the Fat Man, and I've worked on a lot of games for 25 years. But I also do real music, quote unquote. But anyway, the aesthetic, I think, is my friend Tom. I don't know if he's here, but who built me Excaliburrito, which is along these lines. And what you do is, it's somewhere in the music, towards the camera. The camera loves me. If you have a spot in your music where you go, something really nasty would fucking sound great here, and then you wire in Excaliburito, and there's a sort of threshold that once you're ready for something really like awful right there, then it never goes below a certain threshold of awfulness. It only rises rises in greatness. So you learn to like roll with it. It's like Excaliburito can't make a sound that isn't the glorious Excaliburito sound, and I believe that these are probably along those lines. And Jonathan Colton uses it in some of his songs. I use it in regular songs too.
Okay, and with that, I think we're going to wrap it up. And I just wanted to remind everybody, I'm here from California filming the event, and so if you want to buy some DVDs, they're $15 a piece, $10 or $10 a piece if you buy 100 or more. And they're out there on the table. We basically have the entire conference. If you're watching at home, the website's www.mediaarchives.com. And I want to thank you guys again for being here.
Yep.
This is awesome.
And I want to say thanks to NOTACON, to Block Party for having us. It's been a lot of fun. We're going to be over in the front room at 7 to answer more questions, or we'll be all over to answer questions. But if you want to work on stuff, so thanks a lot.